Navigation screen. Share. Okay, so for today, we're going to talk about data security, cloud, and virtualization in enterprises, mostly cloud and data security. Um, this is the next portion. Note seems long, but there's a lot of images, so it should be all right. And then with that, we want to also open up our assignments. Okay, so the first part of the notes, it talks about data loss prevention on your DLP. I think we touch on this. We mentioned it briefly in the last couple of weeks, but we want to get a little bit deeper in how we would secure data and prevent data loss. So when we talked about network infrastructure security, we touch on using firewall or unified threat management system, your UTM, to be able to control or monitor, right, threats within, and that will be related to your payload or your data. Now, in cloud environment, you can use Cloud Access Security Broker, your CASB. You're going to hear this over and over again, to protect organization users. And then in the application itself, you can also set rules. They're kind of like application policy, but within the application, you can control how that application is used to access data, or the data related to that application. So in your assignment, it asks you what type of systems can be used for data loss prevention control. So in the text and also in your notes, it mentioned your next generation firewall, which is, I think we covered that a couple of weeks ago. Now, if we don't have the next generation firewall, we can also do deep packet filtering through our packet filtering firewall. However, next generation firewall is a little bit more intuitive. It's capable of doing, executing or operating multiple functions. Now, if you're using UTM, and in the last couple of weeks, we talked about UTM. These security appliances, basically, it's catch all, right? So you want to be able to focus on maybe the type of data, depending on the network and the industry or the company that you're working with. So looking at the type of data that's being used and how the data is used within the organization and also outside of the organization. So we have to take a look at data in motion, how data is moving in and out of our network, data at rest, how data is stored within our systems. And then, you might have data that would be archived and so on, right? And then data in use, data that is being utilized by the user or systems on a daily basis. Okay. So the security appliance, their job is going to be filter, and you can also use these systems for the monitoring purposes. Now, for cloud users and data protection, what we can do is we can take a look at Cloud Access Security Broker. And on it, you can do access management with cloud infrastructure. So for example, if I'm using Azure or AWS, I can use credential control and access control with IAM, which allows you to look at the credential of the users and how the users are accessing, maybe file storage and data on the servers or even database. Now, database, usually we would control that through the application itself, and then database have a server management feature that you would go in and control the resource within that database. So if we're looking at like SQL database, Microsoft SQL or MySQL, you would be able to have a management console in that you would control how the data is accessed in the database. But using Cloud Access Security Broker, that allows you to set up the requirements for data access, and that will give you data protection across, right? So that's more of like a broader solution. And then we have to dive a little deeper, looking at the type of data, the system that stores the data, or the storage that store the data, and you'll be able to do that. Any question? Okay, so in the next part, and you can find this information on page 1 of your notes. Now, this class mostly address solutions that would fit for enterprise, right? So you're gonna see cross solutions from software to hardware to different areas like cloud and virtualization. So we want to derive security solutions across, right? Making sure that we implement defense in depth, ultimately to achieve CIA. So this is one area that you tend to see that there's a fall down in a lot of organization is the use of USB and external media. Outside of the bring your own device to work, and that's part of the wireless component in the infrastructure. But when you're looking at external media, possibly attaching an external USB, or a storage device, or connecting, their device to a computing system inside the organization. So with that, in the Windows environment, what we can do is we can take a look at group policy. Now, group policy can span across the enterprise or the domain. And then you can take a look at the local policy. So the true difference between these two, right? The local policy is really pertain to that specific system that is being in use. So if I'm sitting at a computer and I'm attaching my USB to that computer, we can carry the policy across through the domain. So if I'm logged into the network, then group policy can be applied. But if I'm not logged into the network, I'm logging into the actual computer itself, right? Like you have credential that you can log into the computer, like your home computer. That's to the local system. Or you can log into the network, like how you would log into RCCD. That will be applying group policy. So group policy entails the rules on how you can use that the system itself at the local level or the system within a network. So with this, what we would see is we would see something like this. Now you can use a template to be able to test your policy. In Windows environment, you can definitely do that. I think I showcased some of that in 48, but you can also control some of this at the local policy level. So in order to open Group Policy Management Console editor, you are going to use GP Edit, or you can, search for it and then be able to pull it up. Here, what you can see is you can see that we have a removable storage access where you can specify, right? So you see by default, it's not configured. So the vulnerability for us is when things are not configured, the system doesn't know what to do, right? It would just go with, ideally they designed it to be with least privilege, but not configured, it doesn't mean that it's denied or allowed, right? So you have to go in there and specify the level of access that you want for a specific group or system, right? At the domain level, what you can do is you can utilize organizational unit, system information, or other area to allow or deny access. So here, what you can see is you can see removable disk, deny execute access. So if I have an executable file And that would launch as soon as I connect my USB, and you tend to see this when you know, an external threat come in, somebody attach the USB to your network to be able to transfer or execute malware physically, right? So you can set deny or allow, right? You know, even though floppy and CD are legacy devices in our system, it still makes Microsoft lists, right? But you can set the type of disk that you want or you don't want. And I think, you know, most organization, they disable the USB connection because they don't want someone to, you know, run like a live USB, a different operating system. For example, I can put a live Kali USB, right, and be able to attack your network. As long as I attach it to that system, I'd be able to use that system because it's already connected to your network port to be able to attack your network. So we should disable that USB. Sometimes they would disable the front USB and allow the back USB because mouse and keyboard and other devices that would be attached to the back. So you have to really consider the type of operation that you need. You know, and some organization they would allow all, but that would be a high risk, right? So then you also have print blocking. And print blocking is just disabling the print capability. If the user doesn't see it, they likely will not use it. If you don't allow them to print, don't add the printer, don't allow that credential to be able to access, you know, different printing systems. So in organizations or things like hospital, you don't want people to print out healthcare information. And sometimes that will go into the trash bin and somebody can do dumpster dive. Also, they also disable screenshots. So in some organization, you would see that you cannot print screen. But then, you know, some user would go to the extent where they would use their smartphone, be able to take pictures. So, you know, with that, we want to maybe, you know, survey a little bit more and control whether that screenshot gets sent out in email, or, you know, messages and things like that. So we would monitor the payload for that. But screen grabbing is, you know, is probably very important as well. So you can control the application itself, or you can also control the level of access through the user account, right? So we can do device, right? Object or subject. Okay. So we already addressed number 2. So the additional security control, and I kind of threw this in because I didn't want for you to kind of go through each and every single one of them. We're going to list some of the priority things that we need for DLP. And you can look at those sections starting from page 1. So additional security control for data loss prevention. We want to block external USB storage access, I should say, connection. And then we want to implement print blocking and screen grabbing. So, no, yeah. Screen grabbing prevention. I meant print and screen grabbing blocking, but so we want to implement print blocking rules and screen grabbing prevention rules. This will prevent the user from, you know, taking the information that they see on screen and putting it on, you know, maybe their device, because we don't allow the attachment either. So data leak can be a big problem for the company. Someone can take the data and be able to sell it, or, you know, use it to leverage their job or their future job. So we want to make sure that sensitive data, personal identifiable information, organizational secrets, those things gets, you know, protected. Then the area of remote desktop, this is really important now that we do a lot of remote access. So remote desktop, privacy, storage, and device control. So Windows uses RDP, remote desktop protocol, and within it, you can set up the criteria on how the system is connected through RDP. So when I'm using RDP, I can directly connect with another system using key-based access. So my communication is encrypted. So that means that we also need to make sure that the data that's being transmitted across the network and how the communication is used, right? So we make sure that we have storage, protection, privacy for the remote desktop, and we also have device control because the device is used for remote desktop, right? Using VPN is also a good practice, but where the data is stored, right? It could be stored on a local system when I'm remote into my workstation, be able to pull data. At this point, my data now is on my laptop, perhaps. So we want to also control the permission for data. Maybe read only, maybe I cannot download the data, I can only view the data. So we have to take a look at how data is being accessed through remote desktop. And then some of the other areas really for deterrence. So if you use watermarking, like company's logo for watermarking on the document, that would, you know, I guess, display the originality of the document, who created the document, who owns that document. I think watermarking doesn't really prevent you from taking the documents, but it just, you know, deters some people from, I guess, grabbing the document. But if they really want to pursue the document, I think you have to do a little bit more than watermarking, but that makes the list for additional control. And then copyrights and document duplication control, this just means that you can't, when you're accessing on the web, you cannot right click and choose copy and paste or, you know, or even download. Copyrights just give you the legal ownership of that particular work, right? So let's say that you have a document that contains important design and you trademark the design. You want to copyright some of that, maybe the research for the prototype. Copyright protection lasts for the amount of time that you copyright and pay for the copyright, right? 7 to 10 years, depending on the type of copyright. So what you want is you want to kind of, you know, look at the ownership, right? And this can get into intellectual property theft and some other areas. So digital right management, you know, when we're dealing with software or documents, work that company produce is important. So when you're looking at people that make music, right? And then they would produce their album and they would copyright that album. So anybody who use their music have to buy the license for their music to have some use of the music. If I use it for a commercial, I have to ask for permission and also pay for the music, right? So it really gives the ownership back to whoever create that particular work. Is it really truly an area that we can implement full control? No, right? It is something that we can use to for legal protection purposes. And then we want to encrypt network traffic. So using SSL, TLS for web-based traffic. If you're using VPN, you can use IPsec. And then with that, we have to also think about email encryption and file encryption. So network traffic is really broad, right? It really depends on what kind of traffic is being passed through. So if I'm accessing my email and I have private information on my email, I would use email encryption. And that can go back to pretty good privacy and other protocol. But for the most part, when you're looking at network traffic, web-based traffic, someone who's visiting a website, usually using port 443 or, HTTPS and so on. So we want to use encryption based protocol and implement that in our network monitoring systems. And then we can whitelist the URLs. So what you allow for the user to access. And you can do it several ways, right? We can do it through application-based firewall. That means software-based firewall, or even, operating system-based firewall. We can also do it through proxy, right? Proxy allows us to control because it negotiates the type of traffic that it passes through the network. So we can and then of course security appliance will be good for doing this. So whitelisting just means that we create a list of all the acceptable websites, URLs that we allow the user to visit. Now your whitelist should reflect the user access. So you would have to establish a baseline in order to build an effective whitelist URL mechanism. And then we would use firewall. And the reason why it says deep packet inspection, right, is because the majority of the firewall does packet filtering, right? Packet inspection. Now, packet inspection is going to give you, performance and throughput. However, packet inspection, if the packet is encrypted, sometime it is a little bit more challenging for packet inspection to analyze the packet. And then if they use obfuscation, it's a lot harder to identify the payload in that sense, right? Encryption can be used in both ways. So if you can encrypt to protect data, they can encrypt to protect malicious data. And then we would apply data classification policy. So this is a whole area, right? So what you do with data classification is the time that you create the data, you have to say what kind of data it is, right? The category of data. So let's say that I create, someone comes into a doctor's office, fill out some forms to become a new patient. The person, the receptionist, or, whoever that sits at the front desk would take that form and scan the form into the system. At this point, we create a whole new set of data for that patient. It goes into the database, right? We would then classify that record in the database as private data, correct? Because it contains, and then private health data is because it contains, their health history, some information like that. Now, someone walks into the office, right? Maybe offer to sell something, right? That information gets input into maybe an email to the doctors or the nurses, or general information, right? That data is then not, we would then classify it differently. So the type of data that you work with, from the point that it's created until the point that it's stored, we have to really take a look at the type of data, right? How it should be classified and what categories it should belong to, because that ties back into, what kind of protection measure that we would have for that data, right? Should it be encrypted? Should it not be encrypted? Private data or sensitive data, we would encrypt, right? So if I need to send out the health record information to the pharmacy or another doctor, like a specialist for referral, at this point we would then need to protect that data with encryption. So before it gets sent out, right, we also use encryption in the channel that we're sending it out, but at the same time we would protect that data, where it's stored and when it's being sent. So this is a general list, and basically you can go through all the sections. You will be able to put together this list starting with page 1. Any question? So here's some screenshot. And then this just shows you the process with RDP or remote desktop. And we talked about watermarking. So now, content filtering is a big area, and it is important to prevent data leakage. So the big area that you should focus in content filtering is with your email system. A lot of data is being leaked through email. So you can have an automated approach. It's really simple. You can set the rules on what to look for, right? Because if someone is sending out things that looks like social security digits, right? It should block it, and it should ask for authorization for that email to be sent out externally. You don't want people to send out, you know, sensitive information. We can specify it. So basically, this is a way that we would select the type of data that we want to block, right? And that's through a software or a system, a security system that you can implement. So let's say that this is the email system. You can specify the rules that it should block social security number, maybe driver license, tax ID, etc. Okay. Now, how do I know the type of data it is? You have to tell the system what kind of data it is using label. So when you fill out a form online, let's say that I want to go to a doctor's office, right? I would register myself. When you fill out the form, each of the field get placed into the database, and it is labeled for that data, right? And so later on, if they need to run a report or submit a group of data to another system, it is a lot easier to process. So when I fill out my name and my information and my social security number, my driver license and address, right, the field gets labeled for the type of data that I'm filling out. So once I click submit, it goes into the record of that database or the table, and the field, right, gets put into the column, you know that, for the SQL. So with that, the social security number gets a label. And with that label, we can then protect that field or, that particular column from being accessed by a certain individual through the database management console. Now, this is often done through programming itself for the web form. So the developer, they would say, once it clicks submit, it goes into the database. This, it's going to add to the field, and it's going to have this type of label. Now, if we need to do this manually, okay, you take the piece of the record and you would use tag-based type of system or attribute. So metadata, as you learn in forensic, is important because it really tells you about the data, what it is, what kind of data, what file type it is, and you can use it to tag. And you guys do this all the time when you add the hashtag online, right? We do a lot of tagging with images because for the system to recognize the kind of image it is or the content of the image, we tag it, right? So let's say I post a picture of a car, right? And if I tag it car, right, hashtag car, hashtag vehicle, all of that is it gives, right, the tag to that particular file. So when I upload it to, let's say, Instagram, right, Instagram server will take a look at that tag and then that's part of the metadata. And that's how it's able, so when you search car, right, in your library of pictures, that tag is then used for search mechanism. So the metadata and the attributes and the tagging process really help you manage the larger data sets in the long run, okay? Now, not all users will be able to tag everything, right? We can tag a lot of different things to that particular image, but what we want is we want a standardized way to tag it so that way it is easier for us to locate the data and control that data. So imagine for Facebook and Instagram, they have what, millions of users, and each user would have a lot of uploads, right? So in order to manage it, they would have the container where the user would upload their picture, but a mechanism for that user to search. So if I upload that picture 4 years ago, right, I should be able to use it. And now you can incorporate AI, right? AI would identify the image and it's gonna say, oh, this image looks like, based on how it's trained. So when you take a picture of a flower, right, it's trained to identify the shape of the flower, right? Maybe the color of the flower, maybe petal shapes, and be able to determine the type of flower. Then it should be able to provide you, some kind of tagging mechanism with it. So I think the automation with AI can be efficient for the larger use of data. And then we can also teach it to secure the data by saying, if it contains maybe a child face, then that becomes a sensitive image, right? Anything under 18 that should have parent permission to be posted, because if there's nudity or any kind of explicit image, we can teach the AI to do that. So I think labeling and classifying the data is critical. Yeah, the image here is just tagging. Also, you give you geolocation, right? And sometimes that can be of importance. Using data with mapping mechanism, I think that a lot of our analytics now is critical, because we really tie like how things are used in certain part of the earth, the world, right? Okay, so this is a screenshot of an attribute of a file, right? Like if you right click a file and you go into the description or the details or the general description of the file, you would see some information like this, the property of the file. So the property really contain some file attributes, and that can be of importance for file recovery, backup purposes, and then, the nature of the file. So when you're dealing with like large binary files or application files, sometimes, looking at attributes is important. Okay, so let's talk about the next part of our notes. So number 4, what file component are used? I'm sorry if you're still working on that list. What file components are used to categorize, organize, and find large files in storage? We would use metadata and file attributes. This is a good way for us to standardize, right, the categories of data that we work with. We can organize it in folders, containers, drives, even servers or cloud servers. And it also allows us to quickly search for the file. So when you're working with audio, image, application files that can be very large. And so that's helpful when we use attributes and metadata or the tag. Any questions? My server randomly shut down. That's not good. few minutes to copy. Okay. And then for number 5, what is the first step in data classification? We would start with, of course, the first step is really to create data, right? But let's say that if the data is created, for data classification, you need to label and tag data. This is going to help you determine the category, the types of data for the classes, like public, private, confidential, right? So after the data is created, we would label the data and tag the data. Okay. So I think most of you got that. Any questions? And in this section, it talks about how we can make things not too visible, right? We can hide things. So obfuscation is a way that we can hide things. But with the implementation, we need to make sure that we have strong access control lists and data encryption. It is effective with this. Okay. So a technique that they say here is data tokenization. And it would be like having, so when you're processing your transaction, let's say you go to the store and you insert your debit card, right? You purchase, let's say, a cookie. With that, tokenization gives you your payment information is not contained in that transactional. You notice that when they print your receipts, right, it only contained minimal information. So the bank has a unique token for that particular transaction with the chip. So when you're looking at the payment information, it doesn't have it's not stored, right? Like things like your expiration date, the what is it called? The code that you have in the back of your card, your security code, the 3-4 digit, whatever, in American Express is in front of the card, right? So that's considered sensitive information and it gets stored somewhere else. And so that means that when they're processing the batch from the database, it's only accessing a different class of data from that transaction, right? So when your account is updated with the bank, it only updates with things like transaction number, the amount for the transaction, the location for the transaction. So in case that you have, if you go back and you say, no, I did not make that purchase, right? They have the transaction number that's related to that. So in that relational table, what they're doing is they're using that transaction as an ID to relate to other fields. And when you look at that, right, important sensitive information doesn't get placed into the statement or your receipt or, some area. So that's part of data tokenization. Okay. The token only contains payment details, but it doesn't contain like, your full account number, expiration for your card or security code for your card, right? Because someone can get a hold of that and they can use that. So it took us a while for PCI DSS to implement that. And now everybody in the financial world has to, isolate some pieces of data. Before, if you look at maybe 20 years ago, it can, when you look at a statement, there's full account information and a lot of information that this is why people would go through the dumpster and be able to have to fake someone ID and get a credit card and issued to them, right? There are other ways now that they do for that purpose, but we have requirements now, regulation now that's in place. Okay. So when you're building an app like Google Pay or Apple Pay, all of this has to be considered, right? We talked about that last time with development. Security is the first ground in development now. Before, it's like an afterthought. Oh, okay, it works. And then now what do we need for security? So now you implement security with design. And then you data scrub. So data scrubbing, like I mentioned before, earlier we talked about database, right? So when we enter data, likely that we're gonna have error in data. And if you work with data sets, there's never a clean data set. Even if you design it, right? Sometime you're gonna have dirty data. Like when you have user input. So for example, web forms, people fat finger, right, their information, right? They mistype their names, so some of that you can autocorrect through development. You guys ever fill out addresses and then it gives you address suggestion, right? That's a data scrubbing mechanism through development, right? I think that a lot of these mechanisms can be automated that way, because address, geolocation, zip code, we can clean all of that up. Now, when you go through and clean up data, sometimes you have to look through, or automate that. So errors can happen when you merge databases. Sometimes that can also occur. You have duplicative data, right? And then you would have to remove one record compared to the other. For example, I go to a website, I create an account, right? Using one email, same information, address, age, all of that. And then I forgot about it. I go back to the website, I create another account under another email. Then I go to the store and I'm trying to use both account for discounts, right? It becomes a duplicate in the user aspect. So what they would do is they should be able to match up the data on the database, right? Look at how those records are identical but different in email addresses, and then ask the user to opt out on one of the account if they're using both account, right? Usually people only use one account at a time, so you can retire one of the account. So cleaning up and scrubbing, so how is this related to security? When you're dealing with duplicate data, right, that is a flaw. And so someone can also create multiple accounts and go in and be able to access that particular record. So what you want is to make sure that your data is accurate and less error. And then it talks about data masking. Make it look kind of real, but not real, right? That's part of obfuscation, is to make it look realistic, but not real. Almost real. So for number 6, it says, describe data obfuscation technique in security enterprises. And I'm pretty sure if you took Security Plus, you've seen this. So we'll start with tokenization. Sensitive data is not stored within the token to avoid data leakage. Then we have data scrubbing. Correct and detect error or missing data. or duplicative data. So that's considered error. So for the data analytics people, right? Data scrubbing is a big area. So before that you can work with the data set, you have to treat or clean the data set. And if you go through the cybersecurity program for Cal State San Bernardino bachelor degree, they also require you to take big data, or basically that's data engineering course. And then you would mask the data. So make it look realistic. And, you know, the book gives you example in that you would use this for like demonstration. So for example, if I need to demo, you know, to the IT team, I would use the data that looks kind of real, but not their arbitrary data set, right? But in that sense, you can use the real set of data and then make it look realistic, but doesn't have the content of a real data. Fine. Just want to make sure I have enough drive copy for everybody. We'll copy an extra one just in case if one fail. So we know that there is data at rest, which is data being stored, like archive data. Data in motion, which is data that's in and out of your network, right? Like web data. Data in use, data that's being used, like your file that's open. For example, your Word document that you're currently typing on, that's data in use. And so in each type of data, what we have to do is we have to take a look at the possible security solution for the data, right? Web data or data in motion tend to have encryption like SSL, TLS. Okay. And then data at rest, we can use encryption-based tool. So when you're encrypting file, we can use OS-based tool, right? Like you can right-click the file on Windows system, and then you can select encrypt, and it would use EFS, which is the encryption tool that Microsoft incorporated, encrypted file system to encrypt that file. Same thing with folder. And we have to use NTFS file system for that. Now you can also use a software to encrypt file. And then in some database tool or a management tool would have capability to encrypt database. So when you're storing up the file that's not being used, we can encrypt it, right? We would, now, even if it's in use, we can use encryption, but every time that they use it, they have to decrypt, right? And that would take resources and time. So encryption doesn't always become effective. Some encryption tool would be heavy duty and it would take a lot of resource and time. So encryption is not always the perfect solution for things. Whenever you see encryption, you always consider resource as an overhead for your file or, you know, web activity or traffic. So we would use TLS, SSL TLS for data in motion, like your web data. And then email data is also data in motion and data is in use, right? It kind of fall into two categories. And we would use email encryption. And then when it's being transferred from one system to another, it's still using a lot of the time, it's still using protocols that belongs to this area. Okay, so with that, I'm going to switch back to it real quick. Okay, so encryption is here. We should know when to encrypt and know when not to encrypt, right? So if you have a sensitive label for your data, then that gets encrypted, right? So the label is going to give us, you know, what kind of security measure that we're going to use. So here's your data life cycle. First you create, right? When I create, I have to save it. So store. Once I store, I need to retrieve it, use. Once I'm done using it, historical data goes into an archive. Basically, it's just a storage area where data that doesn't have much use lives, like historical data. And then once we're done with that, we're going to get rid of it. So destroy. So first, we're going to create data, store data, use data. And when we use data, we have to classify the data, right? And when we store the data, we have to make sure that it goes into the right container, the right place, so that way we can manage it. And then we would archive the data. And there's security measure for archiving too, right? We want to permission protect it. So if you have no permission to access, you know, certain type of data, right, it would disallow you. It would not allow you to access it. And then we also have procedure on properly delete and purge the data. And then we also have to clear out the storage that used to store the deleted data. Because when you delete a file, you know that, you know, there's a slack space. It doesn't really completely go away, right? So you have to properly purge it. Okay. So for the backup portion, so here this breaks down in important things to know when you archive, you have to look at your data retention policy. How long are you retaining that data for? The type of data that you're going to retain. By this, you have to look at regulations and requirement for the industry. So data classification and retention, they always go together. Those policy, right? The list of rules or the document that contain that rule. And then with that, we would configure our system. So let's say that we only need to retain the data for 3 years, which is what you often see with like your text message and communication, right? By regulation, a communication company only requires to have your text message and your communication messages saved for 3 years. And then beyond that, they're not required to do that. So that means that we have to back up the data, right? Archive the old data. So your text messages from, I don't know, 2022 gets placed into an archive. But one day you might search through your phone and you need to pull it, right? If it's not stored locally on your system, you might have changed phone, right? You have to probably access it. So they're not required to go beyond that, and then they would purge all the old stuff. So if the court subpoena for things from like 2019, they might not have your data, right? Sometimes they do, sometimes they don't. So, and then now they're trying to go less, because I think before it was 5 years retention, and then now I think most communication, because of the massive amount of user that they have, they only retain it for 3 years. So if someone commit the crime, right, and like say fraud, and they put it in text messages or multimedia messages, and then that gets go through forensic, and then they go to court, yeah, they can definitely subpoena for the data. But the company can also deny the request if they don't have the data. So if they say that, you know, that account has been closed for a long time, maybe a year in, they might not have the data. So that's because they already removed the data. So things like social media, when you delete your account, your data doesn't go away. You have to request them to remove the data with that account, right? Because when you reactivate your account, guess what happened? All your pictures, all your files come back, right? So you have to you have to go through the request process, and sometimes they don't do it, and sometimes they do it. So I had request a company. So my data was leaked with a server that was with the company, and then that company now is bought out by another company. So when I went through and I looked at where my data went, and it showed that this server leaks my data, so I had requested them to completely remove all traces of my data, and they did. It took them close to 7 months to do that. So they responded like within maybe a couple of months, and then eventually they said that, like, you know, and I wanted evidence too. I was like, I want you to show me that all my data is gone, because I know that you have backup of a backup of a backup. So I want to make sure. And so they did like screenshot a few things, and they showed me that my data is completely gone. So it takes a little bit of effort to do that. I just don't want because their system has been jeopardized. Now it's owned by someone else. It could be leaked again. So I just didn't want my data to be leaked again, right? So that's one way you can clean up some of your data. But it takes so much time. Okay. So let's talk about backup. We always start with the full backup, right? But a full backup takes so much time, so we don't perform a full backup every day. You can, but it's not recommended. So let's say that your company opens Monday through Friday, 8 to 5, right? Like our college. No, we open a lot longer, but let's say for most of the staff operation, it's 8 to 5. So the first backup would be a full backup, and then we would build on the full backup, right? So if I have a new company, I would start with day 0 full backup the first day. Or I'm sorry, I should say day 1. Then after that, we would do a differential or an incremental backup. The difference between incremental and differential backup is at the end of the week, let's say Friday, the incremental backup take less storage than the differential backup. Now it depends. If you have a lot of changes in your organization throughout the week in operation, even if there's more storage requirement, differential is ideal. Like, let's say that I have a lot of customer coming in and there's a lot of transactions and so on, right? Now, backup operation, we have to consider how fast can we back up and how fast can we recover. Recover usually always double, right? In my opinion, a lot of people assess, like, if I back up 4 hours, it takes me 4 hours to recover. Guess what? Right? It has to unpack the backup file and then put things back. It takes time to put files back and OS and all of those things. So you're always going to have the extra time when you recover. But incremental definitely require less storage compared to full and differential. And differential, basically, let's say that I start my full backup on Sunday. On Monday, I added 2 files. So it's gonna back up those 2 files in addition to the full backup. And then on Tuesday, I added, let's say, another 4 files. So as you can see, the more differences you have by the end of the week, your differential backup is larger. It builds on the differences from the full. So on Tuesday, it's gonna back up the differences since the full backup, which is 6 files, right? So the 4 plus the 2, and so on. So as you can see, differential grows more. So By Friday, I might have modified 100 files. So it's going to go 100 and then the differences throughout the week. On the incremental, it's only going to be the differences for that day. But when you roll the recover for the incremental, you have to first recover from the full and then the subsequent, like Monday, Tuesday, Wednesday, Thursday to get the Friday. For the differential, you're going to roll the full and the difference on Thursday to get your Friday back. A lot of students don't understand the difference like that, but if you imagine it, right, that's going to help. I think I covered this in 27 as well. Okay. So your notes. And then I didn't put any questions for FIM, but file integrity monitoring, right? We looked at hash and changes in hash. Now, in the case if you have malware, it loves to modify file, and that's the nature of malware in general. Okay. So when you build a business continuity plan, we'll talk a little bit about this down the line, right? Yes, sometime in your security education career, you will have to write these. Whether you write it for a living or you do it for class. And in the master or graduate degree, you're going to revisit this many, many times, right? In the bachelor and undergrad area, we talked about this and we're going to make you do it at some point. So I think in my CIS 27, we looked at your recovery point objectives, your RPO, right? The hours that you can have to recover when you have downtime. So, and so in regards to operation, we always consider the policy when we are building out business continuity plan. And without this, right, organization will collapse. And with that, we would have disaster recovery plan and business continuity plan and all of those things. So your backup information is here. It lists the advantages and the disadvantages, and that's where I got the information right here. And then I didn't emphasize too much on the RAID, but we know that RAID 0 is fast. It doesn't give you redundancy because it's stripe, right? It goes from this one to this two back and forth. So if my disk here dies, I don't have the full file. So let's say I have file 1, it writes some of the file in the first disk, some of the file in the second disk. So I don't have the entire file. But RAID 0 is definitely fast because it stripes. And RAID is still being used regularly, right? Even though it's an older technology. Then RAID 1, it mirrors. So you have a duplicate of data on one disk to another. So the downside of this is your capacity is only 50%. So if I have a terabyte here and another terabyte, you would think that I have 2 terabytes, but really it's only 1 terabyte of data, right? Because it's exactly the same data. And then RAID 5, this one, it requires at least 3 disks. And it does do error checking, so it checks for parity. So if you are looking more for accurate data storage, RAID 5 and 6 is going to be ideal. Cost more, also because you require more disk. 0 and 1 only requires at least 2. You can have a lot more, but you have 2 to start. 5, you have to have at least 3 to start. Same thing with 6. Okay. But 6 has more redundancy, and you know the prices of the disk is just also more. So it does stripe and parity, so it does fast and error checking. So if you have two drives fail, you still have data access. But this is the common one. 10 is a 1 and a 0. Stripe and mirror, very common, right? So basically it's a combine of two technology, RAID 1 and RAID 0. So you mirror super important data and you stripe the data that needs fast access. Okay, I lied. So number 10, what are the benefits of RAID 10 for backup? What are the drawbacks for RAID 10? And you can look at the benefits and the advantages and the disadvantages. So the benefits of RAID 10 is that it's fast for read and write operation. And it's very fast for recovery because 0 stripes. And then recovery, you have duplicative data. So from RAID 1. And that means that if you can quickly recover, you can quickly rebuild your data. The drawbacks for RAID 10 include the capacity, right? Because mirroring only going to give you 50% in capacity. Like I said, a terabyte and a terabyte is still going to give you 1 terabyte, not 2, right? You would see 1 plus 1, but no, it's 1. Okay. It's not cost effective because you have the duplicate of data across the same disk. I mean the other disk. So you have 2 disks that contain the same type of data. So it's not as cost effective as other RAID or RAID 0. Okay, any question regarding RAID? You know, if you have studied for A+, you probably went through RAID, right? Or gone through the certification. But, you know, for as long as I teach IT and cybersecurity, RAID is always mentioned in every single class because it is still a relevant backup technology or the disk that you use. Okay, let's talk about virtualization next. So when we virtualize, there are a lot of different options in the market. I think the majority of companies would use some of the main products. And you know that you have to pick the type of hypervisor. Hypervisor that's most common is type 1. Basically, when you're running a software like VirtualBox or VMware Player, be able to play your virtual machine through that software, right, using a host. That's a hypervisor 1. So now the example that you see here is Hyper-V, which is a Microsoft product. Why is virtualization important? It's because it's cost saving and everywhere you touch, there's virtualization in the cloud, which is on someone's server, right? Another company server, at your own organization, everything that you see, it is because it saves money. You can have 100 virtual machines on that one server instead of buying 100 servers, right? So in data center, virtual machine is the world, right? It's basically they use it for hosting websites, they use it to release IP addresses for DNS, you name it, every role in the server environment, right? But you can use it for client systems as well. So let's say that I use thin client, which is a computer with minimal hardware. I would allow the user to log into the network and access their virtual machine and it loads their desktop and the applications. So that way I don't have to spend too much money on my hardware. So type 1, bare metal. So some of the things that you would see, right? VMware, I think some of you have used that before, seen it. You can use it as desktop, but they also have server, which is vSphere. I recommend learning it because a lot of companies use it. And then if you want to go the Microsoft route, learn Hyper-V. You can download their ISO and install the Hyper-V role, server and practice. Really easy. I should have done that lab for the lab today instead, but another time. Okay. So with hypervisor, you need some type of hardware, right? It is a software that's utilizing the hardware, and then you can run multiple virtual machines based on the hardware allowance that you have. RAM, storage, processor, you know. Now on VMware, when you're looking at ESXi, this is integrated as a hypervisor as a product, right? That's a common one that you see. So when you're searching for IT or technical work, you often see this pop up for VMware. Citrix also is very common, and that gets pushed through Zen server. And then Hyper-V is Microsoft. You also got Oracle and other products, but these are some of the common ones. The type 2 hypervisors, you have VMware Fusion. A lot of companies are using this now. So you're able to run things cross-platform when you're doing hypervisor like that. Fusion came out, I want to say, maybe 15-ish years ago. And it was a big thing for the Apple users, right? They're able to run it on Microsoft application using VMware Fusion on their Apple systems. But at the time, Apple was using Intel-based processor. Now they switch completely to ARM. They produce their own processor, right? So with that, VMware development has to grow with it. Because when you're writing software, especially for the native OS, to see that software and utilize the hardware, your kernel level have to have instruction that works with the processor. So when you're using workstation type 2, so when you're using VirtualBox, which one are you using? Today, if we're using VirtualBox, which one are we using? Do we have a host OS? Yes, right? To run our application. We have hardware, which is our computer, right? So here, these are some of the vulnerabilities and threats that you see for VM virtual machines. So having a virtual machine is good. You can contain the environment, but it doesn't mean that you cannot breach through a virtual machine. So VM escape is an area for exploitation to go from the virtual machine into the host system. And then the sprawl, right? So containers can be used for testing and also, other things. You can have container-based applications. In security, I see quite a bit of, especially for forensic. They love using container like Docker. So you would have a Docker, which is a container engine. And then with that, you would install the packages for your applications. But it still need the OS like Linux to run it or Windows to run it. Okay, so we talked about hypervisor type 1 for number 11. That is very common with enterprises, but it doesn't mean that they don't use type 2, like workstation for VMware. when you virtualize the application, it's recommended that you use line of business applications, or I mean, use for line of business applications or legacy application that you need to run across platforms. So virtualization is ideal for that. So for example, RCCD might have a grading system or an attendance system that is no longer being used. This is, for let's say 20 years ago, the archive application can be implemented with a virtual system that runs older OS, like Windows XP. Who uses Windows XP anymore, right? But that application was written for the older OSs, right? So legacy application is ideal in, being used with virtualized environment. And in enterprises, you see a lot of that. Let's say that we're looking at Bank of America, right? Maybe 20 years ago, they used a different application to look at account numbers. Someone who opened an account 20 years ago, they might have, when they process that account, they might have used a different application. Maybe that account doesn't have any activity, and they probably, it's still there, but it's not truly active. They haven't pulled money or anything out of it. So to look into that account further, let's say I need to dive a little deeper to look at the details of that account, I might have to use virtualized application or application that's run on a virtual environment. Okay. So before we get to 13. So your line of business right here and that information for virtualization application, and it gives you some example. Send out. So VDI, this allows you to have data storage, right? And that can be included with the cloud. In the case where if you are using like virtual disk, so here I have a thin client that's accessing the virtual environment. They have to authenticate, and they're given a security token to access the hypervisor, which is as an application, as a software tool. And it's gonna pull their profile and their storage, their data storage from the virtual machine that's here inside our network or in our infrastructure, right? So if I'm remote I'm working from home, I can implement it that way. Or in the thin client, if I'm working on at the facility, it's still gonna have to access the virtual machine, and that's, through the hypervisor, but in the secure network environment. Okay. So as an attacker coming in, I might, let's say, pretend to be someone inside the network, access maybe one of the staff or the chief, finance officer, I don't know, virtualized information. So I still have to authenticate and be able to get in, right? So instead of a real desktop, we can have it as a virtual environment. So Kubernetes, you see some of that, VMware, vSphere, they are sweet tools to be able to manage the virtual machine. Microsoft uses your SCVMM, your virtual machine manager, through Hyper-V. And then the next section is for the cloud. Okay. So for cloud security is fairly new in the industry. I think that we are now a little bit more comprehensive about building security solution because we have the equipment, the tool, and the understanding of cloud now that it's been implemented for almost 20 years. It's still new to us, right? because cloud usage, we scale for different things, and with that, what we see flaws and other issues that comes with cloud. So whichever model that you implement, whether you are implementing cloud for software, right, or infrastructure, your whole network is a rack somewhere else in the world, platform, so SaaS, software as a service, platform as a service, or infrastructure as a service. And then now they have function as a service. Whichever model of cloud that you choose for public, private, and hybrid, you should always assess risk where your data is stored. Okay. So some of the things that we should consider looking at cloud service provider is your data storage protection. What are the features to protect your data? If there are requirements in regulations, because not always that we can just throw things on the cloud and use cloud for different industry. So in the notes and the textbook, you can see that for government agency, they have to go through a process. So they have to assess their baseline in order to validate their requirement for cloud or their desire to implement cloud. And with that, right, they have to also show that they are aligning security measures for the cloud implementation and deployment. And then ultimately, we also need to take a look at costs, the resources that are provided through the service provider, and the location. You don't want to have a cloud company in South Africa when you are located in the United States, because connectivity incurs charge. Just like how back in the day, your parents and people like me call long distance and they would charge, right? So the farther you are from the destination or your server, right, that can also incur additional costs. And then elasticity cloud, a lot of the times it's how much you use and how long you use. So it could be time-based or storage-based. So those are the things to consider in general. And so for government agency, how can they implement cloud governance, right? After doing analysis, they have to submit requests to JAB, Joint Authorization Board. For compliance purposes, and sometimes they would have to go through their own direct agencies. So after the deployment for the cloud, we would need to have continuous monitoring. We want to make sure, because it is just a group of servers that's connected to our network, right? We don't necessarily own that server, we're leasing the server. So we have to continuously monitor, and you have to do that on, daily, right? We monitor, and we want to make sure that we have also auditing mechanism, most likely for FISMA purposes and then other compliant body. Then when you manage the cloud, you have to go through, because if it's federal, right, if it's a government that's federal agency, they have to go through federal risk and authorized management program, which is called FedRAMP. You have to audit security baseline. And annual audit is required. Some compliant requirement would require more than one audit a year. So audit is what? To go in and look at existing problems, right? and then we have to fix the problem. So it could just be your data or access level to your data on the cloud. So your cloud storage. So let's say that I lack security credential to access data. Everybody logs in with one account. That's a big no-no, right? Big audit problem. I don't have encrypted channel or communication when I'm connecting to the cloud server to access sensitive data. That's an audit item. Any question? Almost there. 5 more to go. And then we'll take a break. Chance to wrap up your lab document. I'm done copying your driver. I wish they have a better way for me to do this here or allow me to just distribute it to your desktop. There's a software, but I think we're doing away with it. Plus, I don't have permission to access it at that level, which is appropriate for security. Okay. So we have platform as a service, infrastructure as a service, software as a service, function as a service. So if we're implementing platform as a service model, how do we manage our application data? We need to move the workloads into the cloud storage and protect that cloud storage, right? In some part of this, you would see that we sometimes isolate things, right? We don't keep things together because that becomes a central target. So for platform as a service, your workloads get moved into the cloud for access reasons, and enterprise applications workloads gonna move to the cloud. Now, is that the responsibility of the organization or the cloud service provider? It really depends on the contract. A lot of the times it's at least 50-50. So you have to protect your cloud infrastructure or your cloud, storage and application just as much as you protect your system internally inside your network, right? And then for fast connectivity, when we deploy cloud models for infrastructures, we would use a thing called virtual private cloud peering. This is known as VPC. So when we connect the workload between one service provider, CSP stands for cloud service provider, would allow you to connect to other cloud service provider. So basically you can partner up, right? So let's say AWS and Azure, there will be tenants across to be able to have more connectivity for that traffic. So instead of just connecting to one service provider, you're able to connect through other service provider to your cloud service provider. And it says that the traffic is not routed to the edge of CSP network, and then back into another VPC. So peering just means that you are sharing routing through service provider as business to business partnership. I did this one. Any question? And another area that we should consider for security is segmentation is big for everything, right? But for cloud, we would implement a thing called micro segmentation. So earlier we talked about moving the workload into the cloud storage for the application. In microsegmentation, you would keep the workload separate from the communication because you want to make sure that that cannot be jeopardized, right? So it tells you here that separate workloads in the data center where your storage and your hosted cloud is. And basically, you're going to set up rule to restrict communication between the workload and the traffic. You don't mix those two together. So we would separate the traffic from the workload by setting up the policies. We can also create network zoning to restrict communication between the zones. So in the case that you have a threat that's detected, you should already have network zoning in place, right? We don't want to start with creating the zone then at that moment. Network zoning is very common, so I can have a zone for wireless, I can have a zone for, specific things. So to put it into like the common term, like when you go to a store, right? You walk by and then you look at the top and you would see, one area you would see produce, and another area you would see meat, right? And another area you would see household products, and they would label that, right? So network zoning allows you to do that, is to separate so that way you can restrict things from mixing in. Because in a dynamic environment, if you have too many things that are in one place, it's a lot harder to manage and monitor. So what we want is we want to have little islands of things, right? They still have communication in between, but we want to restrict that communication so that way it doesn't bleed from one to another, right? I don't put meat product into produce because, contamination, right? Same thing in the network environment. We humans think, we tend to keep things separately so that way we can control certain area. And then in virtualization, what we can do is we can have it as an isolated environment. So we can distribute the workload across the segment. So you can virtualize some of that. So the service model is there. There's your VPC's peering information. Here's microsegmentation. You can find a lot of the details there. So with the VM, so you might have like a bunch of different server, right? Like a certificate server for your application. Then we would implement virtual machines that for these roles. And then to access it, we can also add in like application firewall or firewall, because application server tends, if it's a web application, likely it's going to be on the DMZ, right? So you would have the firewall. And then on the other side here, you might have like other type of servers, your database, and so on. But your edge firewall is going to be filtering your traffic that brings people, your traffic, your network traffic in and out. And then when it gets here, then it's going to determine where is that going to be the destination. So if the user is using application, then it's going to go here. So you can deploy virtual machine for that role and be able to control it, but you still need to implement security measure, right? And then we can keep it isolated. So when we say using virtual machine, but we're still going to distribute the workload across, because it is a shared type of workload. You see, each virtual machine has its own role, and you're not relying on the one particular server or one system, right? Okay. For and then it talks about like the benefits. So before we get into jump box, microsegmentation, this is good for zero trust architecture. Okay. It is also a way that we can reduce some of the risks with attack or attack that's coming externally. We can contain things quicker. And then with higher security, we're going to meet more compliance requirements and manage our rules better. So overall, this is an area that we can improve security for cloud infrastructure. Okay. For jump box, this is for SCADA management system. So it will be replaced like this, right? And as we learned previously, SCADA is used for what? You guys know what this is used for? I'm sorry? Yeah. Or it could also be facilities related, things like air condition in the warehouse, lighting, right? I don't want to go through 100 different warehouse to turn on the lights. I want one system to automatically do that, right? I can program it through the SCADA system. Okay. So when you're thinking about like grocery stores, supermarket, stuff like that, yeah, local management can manually do something like that. But in manufacturing, you don't want to have to manually have the human go in and do that, right? You want it to be able to program like 5 a.m. It's going to turn on, turn off the parking lot lights and turn on the building lights. Be ready for the first shift at 6 a.m., right? Air condition needs to be on and so on, right? SCADA system allows you to do that. So JumpBox is a system that allows you to manage the SCADA systems. We take a system and manage another system, right? Very typical. So in the diagram, we would see something like this. And we can also control it, right, by accessing it. So remote administration with the jump box. So I can sit from home and I would be able to control. Let's say on the weekends, I can control, I can manage it. And, so that way I don't have to go to the manufacturing facility or, other areas. But I want to make sure that there's security measures. So the jump box is going to sit behind the main firewall, and it's going to be before the internal network firewall, the other SCADA systems. Okay, so your SCADA systems is going to be behind the second firewall. This is part of the internal network now, right? So coming in, I'm going to connect to it by authenticating through the primary firewall at the edge firewall. And then it's going to take me to the jump box, which control the other system that sits behind another filter system, right? So logically, we can see how this is designed. So when this is being attacked, right, they have to bypass this firewall in order to get to it. And in order to get to the other system, they have to get through this firewall. So it's in the middle of the two firewalls. So for jump box ensure that we cannot execute code or software that would be making our system vulnerable. So if someone is trying to run a script, a malicious script that's going to prevent it, or software or any kind of instructions, functions that would make your system vulnerable. So implementing that additional system is going to reduce that because it's going to look for that, right? It has the rules against those things. So it's going to block it. And then toward the end of the document for the notes, we would see block cloud storage and blob storage, right? I know that I took this from the notes, so you don't have to put it verbatim, but you can find that on the document. So ultimately, what does block storage contain? It's basically contain data, but the data is chunked into blocks. And block will only store a fragment of the data, not the entire piece of data. It doesn't contain metadata. This is ideal for fast response. So if you use something like SAN, block storage is ideal. Now the blocks needs to be closer together in order to access because, you know, the data is pieces into blocks. And this is used by database applications often, but not always. And then for the blob cloud storage, this is used for large binary object like audio, video, images, media-based files, or even documents. Or sometimes it could be your virtual disk image. Like in the case that if you own a forensic firm and you would have a bunch of disk image, or even for data center, we would have a disk image repository. So you can put that onto the blob cloud storage. So these are just the type of storage that you would use in cloud systems. You know, I previously wrote a course called Cloud Security, which now is going to be under the Cloud Administration certificate. I thought about adding it as part of the analyst certificate. It is needed, but at the time, I felt like it was, when I looked at it, usually that course is in the upper division, so it might not even articulate. So it's just with this class now, I think somewhat articulate what CSUSB. But yeah, I might revisit the idea because I think cloud is here to stay and you see it everywhere. So starting with work, you're gonna, having that knowledge is important too. And there are certification for cloud security. So, okay. Any question regarding your assignments? All right, I'm gonna stop recording. Let's take a break. Bathroom.